In this video, we're going to talk about some different types of microorganisms that can cause illness. We'll start by talking about bacteria. Again, very basic level. You can do a whole class on bacteria. I mean, there are classes that exist that focus on bacteriology, and that's all he talked about are bacteria, different types, different varieties, and just on and on and on and on. But again, that's not our goal here. Just a simple orientation, introduction to the different types of microorganisms that may be contacted in the workplace and can cause illness for workers. And those illnesses, bacterial sourced illnesses can be fatal. They can be serious. Bacteria is a simple single-celled organism. It's independent, meaning most bacteria do not need a host to survive. They can survive outside of a host, which is the main difference between a bacteria and a virus. A virus needs a host. It cannot survive long outside of a host organism. But bacteria, most are not host dependent. There are some bacteria that are, but most are not. They multiply by cell division. They can reproduce outside of the infected host. Most are not harmful, and don't need to fix it. That should be a separate bullet point here. Most bacteria are beneficial. They provide, they're a part of our ecosystem. They play an important role, good role in our ecosystem. They're not just out there all making us sick. We have in our digestive tract, as we speak, as you watch this video, there are beneficial bacteria at work helping with the digestive process. Soil fertility. When we think about agriculture and production of crops, soil fertility is dependent on beneficial bacteria in the soil. That, again, part of the ecosystem. Our world does not work without bacteria. Some might even argue that the harmful bacteria, and I would agree with this. I mean, it's going to sound extreme, but even the harmful bacteria, they're there for a reason. They play a role. Maybe the role of the harmful bacteria is thinning the herd. But again, that's maybe getting a little extreme there. But all bacteria, you could argue, are beneficial in some way. They are characterized by shape. Again, we're not going to go into all the different types and variations, but we will talk about the different shapes, the three most common shapes for bacteria. We have the bacilli shape, which is a rod shape. We have the cocci, which is like a string of beads. That's what we see here. Here's the bacilli, here's the cocci here. Then we have the spirilla that have a corkscrew shape. Harmful bacteria can take any one of these three shapes or forms. Just the shape does not make them any more or less harmful as far as being disease producing. Viruses, also a microscopic living organism, and here is a coronavirus. And again, coronaviruses are not a new thing. They've been around as long as we've been around. As long as there have been life on Earth, there have been coronaviruses. Smaller than bacteria, they are host dependent. You could even say they're parasitic. They can't reproduce outside of a host, which this makes them easier to control. The short survival outside the host organism, cannot reproduce outside of host cells, which allows them to be more easily eradicated if the chain of transmission is interrupted. And we are going to talk about the chain of transmission before we're through with this unit, and some simple ways that we can interrupt that chain. Some simple ways of interrupting that chain that can be beneficial to our businesses and our workplaces. We also have different types of fungi and mold. They are parasitic organisms. They tend to feed on, live on dead organic matter. Some do require a living host. Not all, but some do require a living host. They range from microscopic spores to large mushrooms, like we have here. Most of what we're dealing with in this unit are the microscopic variety, but there are some that aren't microscopic. But the endotoxins, the mycotoxins that are often associated with fungi and mold, they are usually going to be of the microscopic variety, the no-see-ums that do the harm. They may have their source in a mushroom or a visible fungus, but when they produce spores, the spores can be the source of toxicity, the source of harm, and those are often going to be at the microscopic level. Fungus and mold can harm us and harm workers in a variety of ways. They can be inhaled, leading to respiratory illness. They can produce skin disease, like we see here in this picture, or there are different fungi and molds that can affect our eyes and result in eye disease. Here we have black mold, a common concern for homeowners and business owners. If you have poor ventilation in a work area that's perpetually moist, you may have the development of a harmful form of mold. Not all molds are harmful, not all molds are a health risk, but some are. As a safety manager, if you had a storeroom that looked like this, you would probably want to bring in an expert for evaluation, have them evaluate, do some tests to determine if it's a harmful variety. Even if it's not a harmful variety, it's probably good to take corrective measures, improve the ventilation. If there's a source of moisture that's contributing to the problem, control that source of moisture. Exposures can occur in a wide variety of work settings. Again, we're mostly talking about work settings. We're not a general health discipline. We're focused on health and safety in the workplace. A lot of work settings, a lot of industries can have mold exposures and fungus exposure that affects workers. And we've already pointed out this particular fungal disease. This is just very common, a fungus of the nails. Big toenails are prone to have a fungal growth. They're easily eradicated. There are medications of the topical variety that can help control that type of disorder. On the right here, on the left, we have dermatophytosis, more commonly referred to as the ringworm, which is a fungal disorder. It's not a worm at all. I think it just kind of looks like a worm. It looks like a ring. So somewhere along the way, people started calling this pattern of rash, a ringworm. Again, the more correct clinical term is dermatophytosis. Now, rickettsia is a type of bacteria, a specific type of bacteria. There are a lot of different types of bacteria. There are a lot of different types of bacteria. Rickettsia, there are several strains of this bacteria. Most variations are host dependent. This is one of those bacteria that needs a host. It's spread from one organism through another organism, primarily when one organism bites another organism. The primary carriers are fleas, ticks, lice, and bed bugs. And here are some photographs of the different carriers. We have a louse, we have a flea, bed bug, and of course, living in Oklahoma, you got to know about ticks. You may never have a problem with lice or fleas or bed bugs, but just about anywhere you go in Oklahoma, there's going to be tick exposure. And ticks are the major problem when it comes to rickettsial-based diseases, and there are a lot of them that we'll talk about. This is just an overview here of the different microorganisms, but we will talk in more detail about tick-borne diseases that are transmitted from ticks to humans, from ticks to other organisms as well. Then we have protozoa, microscopic one-celled organisms that can be free-living or parasitic in nature. We can have free-living protozoa or parasitic protozoa. Some forms will multiply in humans, and when they are ingested or inhaled, or they enter through the nasal passage, once they make that entry and they start multiplying, that can lead to very serious illness and even death. Naegleria is the brain-eating amoeba, which is a type of protozoa. It's very rare that there's a serious infection that leads to fatality, but it does happen. A few years ago, I think they were 12, 13 years old. A young person went swimming in Lake Fort Gibson late in the summer, and Naegleria, one of these amoebas, entered through their nasal passage, and what it infects is the cranium, the brain itself, and it does harmful damage to the brain. And that young person died. And I say maybe once a year there's going to be a Naegleria case that ends up being fatal. I say a Naegleria case that ends up being fatal. Most of them are fatal, but there aren't that many cases each year. There is a video if you'd like to learn more about this particular type of protozoa, this type of amoeba. Take a look at the video. There are other types of protozoa, Sarcodina, the amoeba or antamoeba, Mastigophora, the flagellates, Ciliophora, the ciliates, and the sporozoa. Sporozoas are a little bit different because they don't move. Once they reach the adult stage, they're immobile. They are not motile. Some examples that you may have heard of Cryptosporidium. That's a commonly found in water. But Plasmodium and Cryptosporidium are both examples of potentially harmful sporozoa. Again, not motile, can't move. And here's a diagram of an amoeba. Again, these are protozoa generally are larger than bacteria, larger than viruses, but they're still microscopic organisms. As far as how humans can be infected, they can be infected through the fecal-oral route, through a vector, a carrier, an animal or another carrier of the particular type of protozoa. They can enter through a body orifice, again, found in water, very commonly found in water. And most of the protozoa that are waterborne, they are going to really like stagnant water that's warm. Water above 85 degrees, for example, that doesn't have a lot of movement. That's where, if we go back to the Naegleria, the brain-eating amoeba, the Naegleria loves those conditions. They will multiply rapidly in those conditions. Then we have also different types of worms that can cause problems for humans. Helminths. Well, I'm not going to go into a lot of detail here because I do want to talk about the trichina and the disease from a trichina worm infection, trichinosis. You wouldn't think that this would be a concern in the workplace, but it's been about 7 years ago. We were on a job in Arkansas. A worker has a convulsion. We didn't know what was wrong with him. He hadn't been injured in any way. He hadn't had a head injury of any type, but he went into convulsion, and he was taken to the emergency room, and nobody knew what in the world could possibly be wrong. And it ended up being trichinosis. Trichina infection, trichina worm infection, and serious enough that it caused him to suffer from convulsions and some other symptoms as well. And when we thought, man, this guy's in trouble. None of us were doctors, of course, and none of us knew the long-term prognosis. And I think even what happened, the doctor was even surprised by what happened. To make a long story short, in northwest Arkansas, I think it was Rogers, either Rogers or Bentonville. They performed surgery. They removed the worms. He had about a 3-week recovery period, and he was back to work. Surprised the heck out of me. I didn't think we'd ever see this guy again. But he was able to make ultimately what I would consider a full recovery from the trichina infection. And trichina, it's a worm that the most common exposure, and you've probably heard this, is through undercooked pork. Now, these worms can live in the flesh of other animals as well. They can live in our flesh. And if we end up, let's say we consume some undercooked infected pork, those worms get into our system. They can take up residence in a lot of different locations. The gentleman in Arkansas I told the story about, his worms took residence in his brain and affected his brain functioning. But they can take up residence in our muscles, and if somebody ate us, we could. That's getting a little far out there. Yeah, they could become infected by the worms that were in our tissue. But most common exposure for humans is through undercooked pork, and that's become less of a problem in, say, the last 20 or 30 years, because of more and more of our pork is produced from a factory farm environment where the animals are treated. They are fed a standard diet, much more control in the corporate industrial production of pork now. And so there aren't as many trichina infected pigs out there for us to consume and cause a problem. There still are. How does the hog or the pig get infected? They get infected by eating other stuff, and the worms get in them also. And the free-range hogs that aren't in a production pork facility, those are the ones you really got to watch out for and make sure the meat is properly cooked. We have a lot of feral hogs in the United States and the Tahlequah region as well. If you go out to Cherokee Wildlife Management Area, there are wild hogs. If you shoot a wild hog and eat it, you better make sure you cook it right, because those wild hogs that are free-ranging and foraging, who knows what they're eating, and they may be infested with the trichina worms. And if we eat them, and it's not, cooking kills the worm. If we cook it thoroughly, the worm's dead. It's not going to be a problem. But if we don't cook it thoroughly, that living worm's ingested and takes up residence in our bodies. Fun stuff. I'm really not a pork eater, and not because of that. That's maybe not a bad reason to avoid pork, even though, again, pork is much safer to consume now than it was, say, 20, 30 years ago. All right, that's the end of this video. If you have any questions, let me know. When we come back, we're going to talk about bloodborne pathogens, which is a big deal with OSHA. It's an important issue that we need to consider as safety managers. It's not just because of OSHA that we need to consider it.